The last example I'm going to choose is letter H because it contains trigonometry. Trigonometry is often one of the trickiest types of problems to do, usually when sine and cos are involved, because it almost seems deceivingly like it doesn't matter whether we choose sine or cos to be our u sub. We know that the derivative of sine is cos, and we know that the derivative of cos is negative sine. So it almost seems like, well, whatever, just pick whichever one you want. But we have to look a little bit deeper, mostly, because oftentimes the implication of which one we choose is really going to dictate whether our substitution is clean or whether our substitution gets a little bit more complex. For example, in letter H, if I choose 1 minus sine as my u sub, the derivative of 1 minus sine is negative cos. Now, the negative's not going to be a problem, but how in the world would I substitute this x plus? If I have u over x plus and then some sort of du, I can't move the cos to join the dx and just leave the x behind. I have to leave it all as one chunk of terms. So inevitably, that kind of begs the question, if you can't separate x plus cos x, is u subbing individually really going to help? And the answer is no. So while it might be tempting to choose sine just because the derivative of sine is cos and we kind of think of that one first most of the time, I'm going to implore you here to think about both possibilities. What if you chose x plus cos? If you actually think about it, the derivative of x is 1, and the derivative of cos is negative sine. So it seems as though, by design, this problem was actually meant to be done with x plus cos as our u sub. If you're still not really seeing it yet, I might suggest, and if you have some scratch space, this is a worthy step to do. If you have a hard time seeing substitutions in your head, I would recommend that you kind of split the problem. Think of 1 over x plus cos x as separate from the numerator. 1 minus sine x. And try, if you can, to think of it as two separate entities. The reason I'm saying that is because it might make the substitution choice that we're going to make a bit more obvious. Now, in case you're wondering why I did this specific order, the short answer is it doesn't matter. You could have put 1 minus sine first and then the fraction second. But I kind of did this knowing if the derivative of x plus cos x is going to end up being helpful, I like to usually write it first because that's usually going to be the letter u, and everything else is going to lump together with my du. So delineating my scratch space then, I'm going to let u equal x plus cos x. If I want to make my initial substitution just so I can see where this is going, I know I'm going to have 1 over u. That's from my first split up part of the problem. So you'll notice I'm plugging into my rewritten version, not the original. So I have 1 over u, and then I have this quantity 1 minus sine x dx, which should come from my derivative of my side work. So du is equal to 1 minus sine x dx, just as we suspected. Parentheses are proper notation there, but wouldn't worry about it too much right now. And of course, now I can make my additional substitutions. I have 1 over u, that's already done. 1 minus sine x dx is now a clean substitution for du. So this is looking like a much easier antiderivative. Definitely something that I can handle. Let's just not forget our limits. Our limits were originally in x coordinates, 0 on pi over 2, so I need to convert those to u coordinates. I have x equals 0 and x equals pi over 2 that need converting, so I'm just going to, again, in my side work, give myself a bit of organization there. Now, if I plug in, remember I'm plugging into the u sub. So, as I plug in, and again I'm just doing the arrow so you can see where I'm plugging in. You don't have to draw the arrow yourself. I am going to plug in 0 plus cos 0. So, that means cos of 0 is 1. 0 plus 1 gives me a new u coordinate of 1. And then down below, I'm going to do the same thing. This one's going to be a little bit messier, unfortunately, because when I plug in the second version of things, pi over 2 is not exactly a nice number to have to plug in for x, but we'll deal. I have pi over 2 plus cos pi over 2. Fortunately, cos of pi over 2 is 0, so that's not bad. But I have pi over 2 plus 0, which means my new u coordinate is pi over 2. Again, a lot of this is just quick algebraic mental math, but if you need to, use a calculator just to verify, because at this point, it's more important that we understand what we're doing and why we're doing it than to force yourself to remember a unit circle. Big picture, you definitely want to practice the unit circle, but if for now you need to use a calculator to help you verify things, then go for it. So just keeping things straight here, 0 was my lower limit, so its converted coordinate is my new lower limit. Pi over 2 was my original lower limit, and pi over 2 is my new upper limit. Sometimes that happens, where the conversion really doesn't end up changing something, and that does end up being okay. You just have to do your due diligence. You just have to be careful. Now, of course, I need to actually do the antiderivative. These limits are just for plugging in at the end, so once I do that step, I almost don't need to worry about them for another little moment. The antiderivative now is the most important thing. 1 over u is a known derivative. So that's the important thing here, is to recognize this isn't a power rule question, because you'd have u to the negative 1, which actually doesn't work with the power rule. This antiderivative is ln, specifically ln of the absolute value of u, which when we plug in isn't really going to be a problem. And then, of course, we're going to evaluate at pi over 2 and 1. So lots of vertical bars there, but ln absolute value of u is the antiderivative evaluated at pi over 2 and 1. So I'm going to plug in, knowing full well this is not going to be very nice, because pi over 2 is not exactly a compatible value that works nicely with ln. But nevertheless, we will persist. We have ln of pi over 2. Absolute value is not going to matter just because it's already a positive input, minus ln of 1. Again, absolute value doesn't matter because it's already a positive input. ln pi over 2, we're just going to have to leave as ln pi over 2. It's just a silly looking number. And then ln of 1, fortunately, ends up being 0, so we don't have to write that part. Our most simplified version of things can be left as ln of pi over 2. There's no point in simplifying it much further, although there are some properties of logs you could do. You could call this answer, for example, ln of pi minus ln of 2, if you happen to remember one of those properties that involves fractions. But again, not an obligation. In fact, you could have just as easily left your answer as ln pi over 2 minus ln 1 and gotten full credit. So again, flexibility needed for sure, depending on whether it's an FRQ or a multiple choice style question. But in FRQ type questions where you're allowed to put a box around whatever answer you want, don't simplify further than your comfort zone allows you to. At this point, hopefully you can now use these examples, plural, from all of the videos you've seen to try to tackle at least the highlighted questions B, C, D, G, H, and J. If you have the ability to work ahead now, the next page, page 28, contains more examples that are meant to kind of follow the patterns that we established on page 27. So I won't have a separate video playlist for more examples of page 28. Rather, you're just going to have to kind of think about which closely resembles an example you've already seen and try to kind of work your way through. You'll also notice on our learning plan, there's no real requirement to do all of the problems on page 28 or on page 27. So you can pick and choose. You can definitely choose questions that are either in your comfort zone or questions that you feel like are a bit of a challenge or a stretch, but use your own good judgment. The more you can practice, the better. In any case, now that you've seen some examples, go ahead and try your best to use the answer key and your own sense of what's going on to do as many of these as possible. If you have any questions, don't hesitate to send an email. Include a screenshot if it's helpful, or a photo of what you're working on, or simply a description of where you got stuck, and I'll do the best I can to answer it. Good luck.